guys, in this tutorial we'll go through the full software development process or game development process, which are very similar, and I'll try to guide you step by step. And for this tutorial I haven't prepared anything except for the idea. I'm gonna do a breakout game, which is a very simple yet easy, easy to implement, and sort of good enough to demonstrate basic game development skills, game logic, and things like that. So the first thing I'm going to do is to create a text file called ID or something, and this is where I'm going to type things I will think sort of about the game. Because it's a breakout game, it has well-established rules, so there is no point in coming up with new ones. So there is a ball, bat, and bricks. So bat hits ball, ball hits bricks, and user gets points. Something like that. So if you were to come up with your own idea, then this will be slightly more complicated, because you'll need to put things like basic game logic, and so the design of the game and things like that. As for Breakout, this is good enough for us to start working on something, because we already know what the game is and what the rules are. Alright, so the first thing I'm going to do is to open up Eclipse, my IDE. If your IDE is different, then you might be following slightly different steps. As you can see, there's already Breakout 2 and 3, but these are not using FXGL and Physics Engine. So I'm going to do with FXGL and Physics Engine is going to be slightly different, so it's a new experience for me too. Alright, now that we've opened up Eclipse, click File, New Java Project, name it Breakout. So default settings are fine. You may change that to default JRE instead of the execution environment, because otherwise it might sort of say that JavaFX is a restricted library or something like that. It may not, doesn't really matter, but use default JRE. So next, and default is fine, just click finish. So we've got our Breakout a project, and we got our system library and source folder. We're going to create a new package called, typically it's the reverse domain name, so it's going to be calmsb.bo for short for Breakout. We're also going to create a class, so the main starting point, the main entry point to our game, called Breakout app. This is a convention to have app at the end for JavaFX applications. Yeah, tick the box that says public static void main, and it will generate a file with one method in it, and the method is main, which is the entry point. So to make sure that the environment is okay and everything works, we can do just print hello world, the line that pretty much everyone knows by now, and it runs, which means that our environment is properly set up for development. The Java-C is present, the Java compiler, the JDK is fine. We can compile and run Java applications, and Eclipse will also tell you which JRE you're using, which is 1.8 or update 45. So I'm going to increase size of the font, appearance. Yeah, it should be better. Yeah, if this doesn't run, or if you haven't set up your environment properly, then you can follow video number 2 and 3, I think, on this channel, and this will get you up to speed with pretty much everything. Now that we've done that, we can import FXGL library, which is that one. The link in the description will lead you somewhere here, and you can click on the latest version, and if there is even later versions available, then please use this one, because from version to version the API might change and the code will not compile. So click on 0.1.3 and click on raw. You can then download the jar file. Once you've done that, just first of all create a directory called lib. So right click on the project, new folder, lib. This directory will contain our external libraries, or just one library in our case, which is FXGL. Just drag it over and click OK on copy. So this will add the jar file to the project. However, we also need to add it to the class path or the build path. We can do this by right-clicking on Breakout or the project. Build path, configure build path, and on the Libraries tab, click Add Jars. Find your newly copied jar file, which is the FXGL, which should be under lib of your project, and click OK. The icon just now appeared, signifying that this library is now on the build path. So on the build path, and we can now call FXGL methods and classes. Extends, game application, import that, and implement and unimplemented methods. I'll just move that over here. There's a bunch of methods which we need to override in order for the application to work properly. These methods come from game application, and they will sort of guide you through the process where to put things, like init settings, init assets, and so on. Now that we've tested everything, there's no need to do this. We can straight away call our game application launch, and we can run this. By default, if you don't provide your own custom intro, FXGL library will play its own intro. And there we go. We have a screen and nothing on it. From now on, your environment is completely ready for the game development. Also, the source code will not be uploaded because this particular tutorial implies that you follow every single step to get sort of a feel for a game development process. And I'll try to explain everything as we go along. In fact, I'll be coding as we go along, so it should be pretty clear. So the first thing we'd like to do is adjust the screen or the settings for our game. So we can set certain things like title, which is Breakout, settings, set version. I'm going to call it dev, which will stand for developer version. Settings, set width. I would like to have a top to bottom kind of breakout rather than from left to right, so it's going to be 640 by 960. That should do. Also, we'll be running this many times, so we don't want the intro to be enabled all the time, just for the release version. So we're gonna set it to false for now. So we've done this and we can test it. As you can see, we changed the width of the height of the application, the title, which now says Breakout Dev, and so this is the version part, and the intro is no longer played, which is everything we need for now. The next thing is assets. So because it's a Breakout game, we know that we need wall, bat, and bricks. So we can type Breakout sprites, images, and yeah, this looks like something we can use. Save it to a desktop. If you're good at drawing, you can use your own sprites. And in fact, if you want your sprites to be used in the tutorials, then please let me know and send me an email. We can talk about it. Of course, all the credits will go to you. I'm just using it for tutorial purposes. Open, yeah. Because it's a sprite sheet, I will need to get out, to get the sprites out. I'm going to use that one. You can use any tool you want as long as you get the sprites out. I'm going to use 25. Yeah, that should be fine. Yeah, that's great. Yeah, that'll do. Save as a PNG file. So this is our bat. Now we need to get the ball. This looks like something we could use as a ball, or that one. .30 by 30. Make sure the ball occupies the whole screen. It'll be easy for collision detection and things like that. That didn't work. Yeah, that'll do. Save as PNG file, and we call it ball. And we now need bricks. So just a single texture for a brick will do. Let's take that one. 30 by 30. Save it as brick. Save. Right, so now we've got our 3 textures, and we need to load them into the project. Because FXGL has its own sort of asset management system, the only thing we need to do is create, so select the source folder, right click on it, and create package called assets.textures. Make sure you don't make a mistake or a typo, so it has to be exactly like this, assets.textures. This way, FXGL asset management system can find its textures, copy them. So we now have ball, bat, and brick under assets.textures. Because it's just 3 textures, we could easily cache them, and the cached object is called assets, which we need to import. And in init assets, simply assign or initialize it with asset manager.cache. So basically anything you need to do with asset management, asset loading, use asset manager, and you can cache everything. So what you can do is load textures one by one, or just cache everything. Just to make sure that they are loaded, you can call log cached on assets object to make sure that they are loaded properly. You can now run the game, and as you can see, it says that it found those textures and it loaded them. Bat, ball, and brick. So the next step would be to show those textures on the screen, or rather to initialize game objects. From our idea text, we have so we know what the game objects are really: ball, bat, and bricks. So what I'm going to do is create an enum. So we need to create a type, and the way we do it in FXGL, we create entities, which are game objects. And in order to initialize an entity, we need an entity type, which should be unique. And one way of guaranteeing unique types is to create an enum in Java. So type implements entity type, which we also need to import. We have bat, we have ball, and we have brick. So in initialize game, we will first call init bat, which we'll now implement, then init ball, init bricks, and we'll implement those methods one by one. Private void init bat. We'll probably need to have access to ball and bat all the time, so we're going to be physics entities, physics entity bat and ball. You need to import physics entity, bat, new physics entity, type bat. We then set position, we'd like the bat to be what, in the center, in the middle? Yeah, somewhere in the middle and at the bottom. So we do this by get width, divide by 2 to get the middle, minus, what is the width of our bat? Is 128. So 128 divided by 2. So what we get is, this is the middle point. We then subtract half of the bat width, and this way we place the whole bat in the center. As for y, we need to get height. And subtract the height of our bat, which is 25. We now set graphics, and the way you can get textures from your cached assets, just call assets object and get texture. As simple as that. The key that you provide is the name of the file. So if it says bat.png, you'll need to type bat.png, and as long as it is placed correctly under assets.textures, which is under the source folder, FXGL will find it for you. And the good thing about FXGL is asset management. It will still work if you package it into a jar file using Eclipse's runnable jar, which we will do at the end, at the very end, which is called packaging and deployment, kind of in the game development process. So JavaFX, what else? The bat would like it to be a kinematic physics object. So body type kinematic. Finally, we can add entities, and we add the bat to the list of entities. So if we'll just comment this out for now, we should be able to see our bat on the screen. Yep, there you go. We've placed it right in the middle and at the very bottom by using that. Now, as for init ball, we're going to create that method too. Init ball new physics entity type ball. Set position, by default that should be right in the middle, so let's get width divided by 2 minus 30 divided by 2. I think it's 30. Yes, it's 30 by 30. And pretty much the same for height or for y value. Well, set graphics assets, get texture called ball.png. Ball should be a dynamic object or dynamic body, so that physics forces can be applied to it, and so it is pretty much completely managed by the physics space. Add entities ball. So what this add entities does is it adds the entity to the rendering list, first of all, to the list that it then gets updated, as in the controls of each entity will get updated. And one more thing, because it's a physics entity, it will also add the entity to the physics world, so it is managed by the physics engine. Alright, if we run this now, we should get a ball, which actually already works, I mean the logic and physics. And you might ask why, because we haven't sort of implemented anything logic-wise. It does that because it is a dynamic object, first of all, and second of all, by default, Physics Manager will set the gravity to 010, which means we need to disable gravity. Disable gravity for this kind of game. You don't want to have gravity in Breakout, unless your Breakout is kind of different. So by calling set gravity on Physics Manager, we're removing gravity from the physics world, from the physics space, and hence there is no gravity applied. And currently there are also no forces applied to this ball, and therefore it's not moving. We can now create bricks. So bricks for, let's say what, 30. Physics entity. Since bricks are not moving, they're not moving at all, so we can create them as static entities. Brick new physics entity type brick. Brick set position. Okay, that's gonna be tricky because I don't think we can put all 30 of them in a single row. So the brick size is 30 by 30. So if we start from 0, so that's I multiplied by 30. Yeah, let's just try that. I multiplied by 30. It's multiplied by 40, so that there's a space between them. And just 0. So this is just a test, really, just to see how they will be placed. Set graphics, assets, get texture, brick, PNG. By default, physics entity will be spawned as a static body, so we don't need to set the body type. Alright, that should do it. Yeah, they're placed in one row, and how many of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if we do this 16, 48, that should give us 3 rows. Modulus 16 multiplied by 40, and I divide by 16. Integer division multiplied by 40. Yeah, 40 will do. Yeah, there you go. We got 3 rows, and it should be 48 entities, brick entities in total. So we've now got all our entities on the screen. We now need to add logic, and yeah. No, actually, the next thing is UI. So we'll need probably score, yeah, score text, new text. You need to import this from JavaFX scene text. Score text set translate y 50. Slightly bigger font, 18. By default, the color will be black. It's fine because we have a white background. And we add this get children add score text. So we add this to the root, to the UI root. So it's placed. Oh yeah, we haven't set text yet. So score text, set text, score. And this, here it is. We'll probably need to move bricks down a little bit. So if we start at 100, yeah, that's great. So this is where the score will be. Of course, you can change the whole thing and design a much better level. So input. This is the user input, and in Breakout the user can move left and right. This is pretty much all the input user gets to perform. You call input manager to do it, the input handling or binding. As you can see, there are 2 methods: key press binding and key type binding. If you read the Java doc, it will say the difference between them. So key press is called every time while it is pressed. Key type is only called once per physical key press. So what we need is key press binding. This is the key code. The code will, from a keyboard, basically A. So A will move to the left. This is the runnable action, the variable code that runs during key press. Which is bad. Oh yeah, you cannot call set translate or translate related methods on physics entities. They will just do nothing. So you will need to call set linear velocity. minus 5, 0. So this is in x direction, this is in y direction. Minus 5 means to the left, and plus means to the right. You can do the same with code D and change the sign. Because our bat is a kinematic object, it will not lose its velocity over time, which means we need to set the velocity to 0 so that it doesn't move. It only moves when the key is pressed. So we now can move our bat, which is great. This is pretty much all the user input. Now we need to change, we need to move the ball, and we can do this by setting, first of all, its default velocity. Make sure you call set linear velocity after you've added entities, otherwise you'll get an exception, because you cannot set linear velocity before the entity is added to the physics world. Linear velocity 5 minus 5, because we want so by default we want the ball to move to top first, so there is a certain amount of time before the user realizes how to control the game and stuff like that. And yeah, that should do it. Let's try. Okay, we forgot the screen boundaries. So we're going to do this init screen bounds. Screen bounds are essentially physics entities. Entity top. Oh yeah, we'll also need a new type. Let's call it screen. Top. This is going to be the top screen boundary. So we'll set position 0 minus 10 just above the top frame, and set graphics new rectangle. The collision shape will be determined by the graphics if the fixture definition hasn't been set explicitly. So we'll have to do this. New rectangle, get width, and 10 in height. You'll need to import this from JavaFX. And we'll do 3 more for bottom, left, and right. So that's for bottom, left, and right. Bottom should be placed set position 0, get height. This is new rectangle, get width of height 10, yep, that's fine. Left will be placed minus 10, 0. And it is going to be 10 in width and get height. This is going to be 10, get height. And will be placed get width 0. Alright, that should do it. By default, they will be static blocks. Now we just need to add them to the list of entities. Okay, it is now blocked by the screen boundary, as you can see, but it doesn't move the way it was supposed to, which is because we haven't set the physics properties for the ball. And you can set physics properties by creating fixture definition. which is a class from JBox to the engine, which you need to import from there. FD, what we are looking for is restitution elasticity. So if we set it quite high, 0.8, that should do it, I think. Oh, also, because a ball is a circle, essentially, it is not a rectangular shape, so we need to change the shape as well, because by default it will go down to being rectangular shape, which we don't want, because with physics engines we can do much more precise collisions. Shape, set radius, we need to convert the radius to meters, because if you remember, physics engine deals with meters and we're dealing with pixels, or rather FXGL and JavaFX deal with pixels. So we need to set radius. The graphics for the ball is of 30 units in width, which means this is the diameter, and we simply divide by 2 and we get 15. And don't forget to add the fixture definition to the ball entity. Set fixture definition FD. Okay, let's try that. Yeah, that's more or less something that we'd like to have. But we don't really want it to have such a low speed or such low velocity, because eventually it will just stop. What we can do is on update, yeah, let's check the y velocity. So if ball get linear velocity get y is less than what, 5 units, and we also need to make sure to get the absolute value. So if absolute value is less than 5, we need to set the y value to 5. So first capture the x. We'll then need to get the sign. So sine y, linear velocity, math, that's signum, ball get linear velocity, get y. Or if you don't want to do this all the time, just create point to the .v, import it from JavaFX geometry, and do this. Then we get ball set linear, set linear velocity to x, and sine y multiplied by 5. So what this is supposed to do is, if the y, if the speed in y-axis drops below 5, it will increase it to 5. Yeah, that's more like it. Okay, so we now got basic logic, and the only thing we need to implement is essentially collision handling, which is again pretty easy in FXGL. In initialize game, after initializing all objects, just call physics manager and add new collision handler. New collision handler We first need to import this. It takes two entity types, so this is the collision between type A and type B. In our case, we're interested in collision between type ball and type brick. So we can destroy the brick and get points for that. Add unimplemented methods. You now have three methods that you can write code in. So collision begin is called once when they start colliding. Uncollision is called after collision begin in the next tick if they're still colliding. And collision end is called when they're no longer colliding. So you can sort of keep track of things in the world. On collision begin, we would like to remove entity B. Also, the order of types that you pass in determines the order of objects that you get back. So if you pass the ball first, the type ball first, then you get object A as this ball, which means brick is B. So we remove the brick. Also actually need a score, so integer property score. We need to import both those things. Score set score get plus 100. So we get 100 points for destroying a single brick. Now that we remove the entity and collision begin, those collisions shouldn't really happen, so there is no need to do anything in there. Now that we've created score property, we can now bind the text property of the UI element to score as string, which means that whenever we update this score integer property, the text property of this UI element will be updated automatically, which is pretty nice. Now that we've added the collision handler, we need to make sure that we set both objects as collidables, and we can do this by calling entity, so ball, set collidable true. If you don't do this, then the collision handler will not fire. This is done for physics optimizations, so because collision detection is quite an expensive operation, and if you have lots of objects on the screen, by default they're not collidables, so that the performance isn't so bad. And if the object should not be able to collide with other things, there is no point in checking collision with other things. Therefore, set collidable by default is false. So ball and also the brick. Brick set collidable true. In the previous versions, this method used to be called set use physics, but now that we have an actual physics engine, it kind of doesn't make sense anymore. So I changed the API slightly. So we've set the collidables between for ball and brick, so now this should work. Yay, it does. So when we hit the brick, it gets destroyed, the entity is removed from the screen, we increase the score, which is being updated automatically in the top left corner, and everything is pretty much perfect. The only thing I'm going to do in this sort of tutorial is make another condition for if you don't catch the ball. So bottom, we set collidable true, so we could do the following. We can add another collision handler between the ball and the bottom of the screen. Type screen. Since this is the only collidable, or the only entity that we called set collidable true, this is the only entity that will fire this collision handler or trigger this particular collision. In which case A is ball, because this is the first type. The second type is screen, so the second type is B. B is screen. And we don't do anything, we just subtract 1,000 from the score, which is kind of harsh. But you're not supposed to lose the ball, so I think that's fine. So if you fail to catch the ball, you get minus 1,000 from your score. Okay, so we've covered pretty much everything. And the final thing, like I said, I will show you how to package the game made with FXGL. It is really simple if you're using Eclipse. This should be also simple with other IDEs. So right click on your project, export, runnable jar file, next, select find your Breakout app, which is either here or somewhere at the bottom. So Breakout app, select that. The export destination is desktop for me, and you can rename the file if you want to. So extract required libraries should be selected, and click finish. So this will generate a jar file on your desktop, which you could simply double click and run the game. So this is 100% portable. You can send it to your friend and have it tested, or you can place it on the internet. You could share it as long as the end user has Java Runtime Environment 1.8. So, before release, you could enable the intro, set it to true, export, runnable jar file, select everything you need, finish, rewrite, and double click it. And it will now play default FXGL intro. And start the game. You can also, if the double click doesn't work for you, you can open your command line, go to, navigate to where the file is. For me, that's desktop. And java-jar and breakout app.jar. This will run the game. It'll also throw some information to the command line. Okay, so we've covered almost the full game development process, although it wasn't sort of that thorough, but still, it gives you the idea of how one might proceed with game development. And we got ourselves a nice little Breakout game in just 183 lines, and that's even including all the imports. So that's kind of nice. Pretty much the whole logic is done by the physics engine, which is again nice, because we don't need to do or worry about anything. Thank you for staying with me for the whole video, and thanks for watching.